All right, so today we're going to get into empirical formulas. Empirical formulas are the simplest whole number ratio between the elements in a compound. So if I have something like C4H8, if that was the molecular formula, then the empirical formula would be basically if I reduced it. So it would be CH2 would be the empirical formula. Okay. If it was H2O, okay, that can't reduce or simplify. So in this case, the molecular formula is the empirical formula, and that's okay. That can happen. If it was H2O2, hydrogen peroxide, then my empirical formula is HO. Okay. So again, it's just simply reducing or simplifying to the lowest whole number ratios. Now, there's ways that we can calculate this. So sometimes we'll be given data where we just have the grams. So if I know the grams, 13.5 grams, 10.8 grams, calcium, oxygen, and hydrogen, then I can try and figure out what is the empirical formula from that data. And the way I go about doing that is I take these numbers and I need to turn them into moles first, because that's how I'm gonna figure out the ratios. So I'm gonna do Ca, which is 13.5, divided by its molar mass, which is 40.08 from the periodic table. Do oxygen, which is 10.8 grams, divided by its molar mass, which is 16, and then hydrogen, 0.675, divided by its molar mass, which is 1.01. Okay, so I'm going to divide each one by their molar mass to turn them into moles. Okay, this gets me 0.337 moles. 10.8 divided by 16, that gets me 0.675 moles. And then 0.675 divided by 1.01, gets me 0.668 moles. Okay. So then what I'm going to do, I'm going to look at my moles and determine which one is my smallest amount. In this case, the calcium is my smallest. Okay. So I'm going to divide all of them by the smallest amount. So I'll divide this one by 0.337, divided by 0.337, divided by 0.337. So this equals 1. 0.675 divided by 0.337 equals 2. And then 0.668 divided by 0.337 also equals like 1, pretty much 2, pretty close to 2. So those are whole numbers, and those become my subscripts for this compound. So it's going to be Ca, and the OH is going to be bonded, and there's going to be 2. It'll be like that. Okay. Since there's 1 calcium and 2 oxygens and hydrogens, there is my empirical formula, CaOH2. Okay. So now we can also do it if we're given percentages. Okay. Similar to how we did the percent compositions yesterday. If we're given these percent compositions for a particular compound, we can take those and find the empirical formula from it. Okay, so the way we do this is we assume, since these percentages are going to add up to 100, we're going to assume that we have 100 grams of this stuff and turn the percentages into grams. So for carbon, I have 52.14 grams. For hydrogen, I have 13.13 grams. And for oxygen, I have 34.73 grams. Okay? And then I'm going to divide each of them, just like we did up to the other one, divide each one by their molar mass, 12.01 for carbon, 1.01 for hydrogen, and then 16 for oxygen. So I'll do those, put them into my calculator. 52.14 divided by 12.01 gets me 4.341 moles. 13.13 divided by 1.01, 13 moles. 34.73 divided by 16, and that gets me 2.17 moles. Okay, and so then I'm going to figure out which one's the smallest. So divide by the molar mass, get moles, figure out which one's the smallest. So in this case, the oxygen is smallest. I'll divide all of them by 2.17. Okay. So I know this is going to equal 1, 2.17 divided by itself. 4.341 divided by 2.17, that's going to be close to 2. So that'll be 2. And then 13 divided by 2.17 equals 6. So those, again, those become my subscripts. So it'd be C2H6O. There's my empirical formula. Okay. Again, take these numbers and put them as subscripts next to whichever element they are associated with. Okay. I hope this helps. Let me know if you have any questions.